Okay, so now over to others, please.
Shivam,
Yes, ma'am.
अपना introduction दो.
Good morning, sir. My name is Shivam Joshi, and here I am working in CGWA and environmental sector. Good morning, sir. Myself Sanjeev Kumar.
एक बार सबको बोलना कैमरा ऑन कर दें.
हाँ जी. Good morning, Sanjay sir. Mayuri this side. I'm sorry, I'm having a problem with my camera. So guys, please turn on your cameras who have joined online and introduce yourselves. We'll start in another 2-3 minutes. So before that, let's introduce ourselves to sir. And please be seated.
Yeah,
Keep your mobile phone on silent as well.
सब लोग एक दूसरे से परिचित हो जाए. मेरे ख्याल वैसे जानते होंगे, पर it is a good opportunity to start interaction with the specific domain responsibilities.
Right, sir. Neha ma'am, if you can start.
मयूरी, मैंने आपको एक पीपीटी शेयर किया है अभी.
अच्छा, ठीक है.
ना, वो स्लाइड्स अपन को चलानी होगी. दुर्जॉय सर के यहाँ कुछ प्रॉब्लम आ रहा है.
No worries, ma'am. ठीक है.
है ना? तो
जब तक हाँ, जब तक इंट्रोडक्शन होता है, I'll just download that and I'll share.
Okay, okay. Hello everyone, I am Neha Bhaga, Vice President in Gaurang Environmental Solutions.
Morning, sir. Morning, sir.
मॉर्निंग. बैठो. मैं इधर बैठ जाऊंगा, आपको काम करना है. नमस्ते नमस्ते. और क्या लगे
पीसी सैनी सर, आपको इंट्रोडक्शन दे दीजिए एक बार प्लीज. पीसी सैनी सर, दीपक, कपिल सर, प्लीज. श्रुति, जो भी स्टेज में अप्रेज होने वाले हैं परसों, अपना अपना इंट्रोडक्शन दे दीजिएगा प्लीज सब.
I am PC Sani, Senior Hydrogeologist, retired from Public Health Engineering Department, Jaipur, and now working with Gaurang Environmental Solutions last 5 years as a project coordinator.
Yes sir, ठीक है. दीपक.
I am Deepak Kumar, hydrogeologist. I am working as a hydrogeologist last 1 year in Gaurang Environmental Solutions.
और आप किस फील्ड में अप्रेज होने जा रहे हैं वो भी बताइए.
Hydrogeology and geology.
As a team member, TAE, project coordinator.
Team member. As a team member.
Okay. Shruti.
Hi, I'm Shruti. I'm working on land use maps and land use reports. And I'm appraising for team member hydrogeology remote sense.
Nidhi.
Good morning, everyone. I'm Nidhi Khare. I'm hydrologist. I'm working last year to till now with Gaurang organization.
आप किस फील्ड में अप्रेज होने जा रहे हैं वो भी थोड़ा एक्सप्लेन कर दीजिए सबको एक बार प्लीज. अपना अनम्यूट करो निधि.
Who is introducing ma'am next?
Yeah, this is Mallikarjun. I'm actually a functional area expert for air quality and hazardous waste and noise and vibration, and I'm coordinator for thermal power plants and TSDFs. And the reason why I'm so interested in groundwater modeling, not interested, like I'm inquisitive about this subject is like lately these TSDFs and landfills, they're one more reason for all this leachate coming onto, because most of the landfills which we have as of now are not technically, I mean, scientifically designed actually. I mean, I'm sure like one day all these landfills, they might create a groundwater problem, and this groundwater modeling will play a major role for upcoming projects for all these TSDFs and landfills. Yeah, thank you. I mean, so I would be glad if you can throw some light on this landfill leachate dispersion, you know, how that can be assessed in a better way. Yeah. Thank you.
विमल प्रदीप आप सभी अपना अपना देखिए प्लीज.
Good morning, everyone. I am Vimal, working in industry department. I am a team member in AEP and WP.
Good morning, sir. Myself Pradeep Kumar. I am working I applied for the team member in the NABET, and I am working on the IA projects, mostly on the thermal power projects.
Good morning, everyone. My name is Rajesh Saini. I am working in mining sector, basically preparation in draft EIA or final EIA. I am attending the session only for the knowledge.
Good morning, sir. I am Chanchal. I am working here in infra and building structures, and I am here for the knowledge purpose. Also, I apply in water quality and water pollution in NABET.
Hello everyone, I am Sapna. I'm working here in industry sector and I applied for air quality modeling and solid waste. Thank you.
हो गया सबका introduction.
Neha ma'am, everyone have joined, so we can start with the session, I think.
Yes. Durjoy sir.
Yes, madam.
सर एक बार अपना इंट्रोडक्शन देके आप प्रेजेंटेशन स्टार्ट कर दीजिए सर प्लीज.
Okay. So good morning to everyone. I am basically D. Chakraborty, retired as a senior scientist from the Central Groundwater Authority and Board, and presently having competency in the hydrogeological solutions. I would be interacting with you on the groundwater as well as some aspect of the introduction to the groundwater modeling. Can I have the slide, please?
Yes, sir.
Is my screen visible?
Yes.
I think मैम किसी का echo हो रहा है तो वहां से आप mute कर लीजिए. And guys, please turn on your cameras जो भी online join किए हैं.
Screen is not visible to me.
I'll reshare it again. So
Yeah, in full screen mode. Yeah. Okay then. Shall we start?
Yes, sir.
Okay. So welcome to everyone on this training program. Let me start with the basics of the groundwater, and then we will interact with you on the hydrogeology and modeling. Next slide, please. So anything on the water, basically hydrogeology, if you talk about, we are a part of the hydrologic cycle, and everybody know about that it is a circulation of the water in the environment. And hydrogeology basically examines the relationship between the geological matter and the flowing water, especially when we talk about the with the formation, with the groundwater. Next one. So basically, global hydrologic cycle, you are very much aware of this thing. It comes with the evaporation, condensation, precipitation, then again infiltration into the groundwater and runoff into the sea, lakes, ocean, whatever it is. Next one. We are more interested in a basin-wise hydrology. So wherever we work in any project and all that thing, we are more interested in them. So what are the components we are more interested is the runoff, infiltration, recharge into the groundwater, what is the base flow into the streams and all that, what is the evaporation or the transpiration, evapotranspiration rate in that area, and what is the total amount of precipitation falling in that area that we are interested. Next one. This is a basically 3D figure which talks about all components of that thing. If you see in the left, we have got the rainwater seeping into the left, please, rainwater seeping into the groundwater, and then it is slowly joining into the water table through the percolation. And the blue one is the saturated one, and the yellow part is the unsaturated one. If you see in the front side, you see the groundwater coming into and joining the streams. Here we call, wherever the groundwater basically joins the stream and it contributes to the stream, that particular stream we call it as a effluent one, where groundwater contributes to the stream. If the stream is contributing to groundwater, in that case we call the stream as an influent one. Wherever we see the water table intersects in the surface, there we get basically the springs or the spring images. Next one. This is the vertical distribution of the water. So you have to have an idea about what is the vertical distribution of that. So you have got some soil water in the top, which is held by the root of the vegetation, and below which will be the unsaturated one, what we call it as a vadose zone. And then the saturated zone is where actually we call it as a groundwater. So groundwater is basically the saturated part in the subsurface formation. And there will be a capillary fringe, capillary rise, which will show some soil moisture above the water table. So this is the vertical distribution. So we have to be very clear about if we are talking about the recharge in that area. So we have to know what is the nature of what are the formation in the vadose zone, and that will help into the recharge into the groundwater system or the aquifer system. Next one. This is the basically 3D, what we call it as a zone of aeration, that is the vadose zone, and the zone of saturation, where we have got the total pore spaces are filled with the water, and we have a water table. Next one. So what we get, infiltrated water. What is infiltrated? That replenishes the soil moisture deficiency if the soil is not saturated. When it gets saturated, then we call it as a groundwater system. Water, basically, the vertical movement, if you see, it percolates down and ultimately it joins into the saturated zone, and we call it as a deep groundwater system or the aquifer. The upper surface of the saturated zone is basically, we call it as a water table or the water level in that area. And the soil above the water table, which is not saturated, is basically the vadose zone. So you have got a vadose zone, zone of aeration, which we call it as a unsaturated one, and you have got a saturated zone. Then groundwater, important part is basically the hydrologic cycle. It is a very important component of the cycle. And to your knowledge, let me tell you, the groundwater constitutes more than 80 times the freshwater rivers, lakes, also whatever you see. So it is the fresh water in the surface, what you see, the 80 times is in the groundwater system. Next one. So groundwater, where it occurs in where the water recharges the subsurface through cracks, pores, or the soil or the rock, and the shallow water table, which you get, is called basically the water table. Next one. So you have got two types of recharge, that is the natural one and the artificial one. Precipitation, melting snow, infiltration by stream, lakes, everything contributes into the groundwater through the vertical movement. Whereas where there is lack of the vertical movement, or there is a confining layer or something, then we go by artificial means, by recharge wells, by pit and furrows, small check dams in the streams detain, and then we recharge into the aquifer system. Next one. Now, what is aquifer? Aquifer is basically a geological unit which can store and supply significant quantities. So here the word significant is very important for you to understand. If it is not significant, that means it is not an aquifer. So aquifer should have a property to store and supply. That means if you pump it out, it can supply significant amount of the water. And this significant is a relative term. What are the principal aquifers what you get? We have got a unconsolidated, this is sand, silt and other. Then we have got sandstone. We have got sandstone and carbonate rocks. Then we have got some semi-consolidated formation, carbonate rocks we have got. We have got volcanic rhyolite and other things. Then we have got other rocks like granite, gneisses and all that, these formations. So different type of aquifers we get in your in our entire earth system. Next one. Now, there are certain terms which are very important. A term is known as aquitard. Aquifer, you know now, aquifer. Aquitard is basically a geological unit which gives water if you view in a large area. The permeability in this area is not very well in the water the production wells. But like a sandy clay, that sort of system, or a silt formation, they are known as aquitard. So you have got sufficient water to store, but they cannot give good amount of water when a well is drilled. Another one is aquiclude. That means a unit, geological unit, which can store water, but cannot transmit. So basically, we don't pump water from this formation. As clay is a aquiclude. It is separating layer between the two. Though it is saturated, but it cannot give you or yield water. And another one is aquifuge. Any geological formation which don't have any pores and other things, it cannot absorb water also, it cannot transmit water also, like a solid basalt, a granite or gneisses don't have any fracture. A compact formation which does not have a capacity to hold and transmit water is known as aquifuge. So now you have got 4 things: aquifer, aquitard, that is a silt or something sandy clay. Then you have got an aquiclude clay, and you have got an aquifuge as a granite or gneisses. Next one. So this is a picture with a layered aquifer system. You have got a recharge area. You have got a piezometric surface. Then you have got a groundwater surface. You have got an artesian flowing well. You have got a confined aquifer, confining stratum. You have got a confined aquifer system and unconfined aquifer system. And you have got a water table in that area. Next one. This is the basically a pictorial view of that thing where you can clearly identify which is the aquiclude is the 2 clay layer which is sandwiching the aquifer system with a blue one, and basically it is a confined condition. Once you puncture this and you try to drill a well in that case, then you can get a piezometric or potentiometric surface above the top of the aquifer system. So it will rise to the, and in some cases when the pressure is very high, it comes into the artesian well also. Next one. Porosity. We want to know that what are the things? The porosity is the portion of the soil which is not occupied by solids. It's basically interstated with the volume of the water in that thing. So the ratio of volume of pores and the total volume is the porosity of that formation. So higher the porosity, the higher the water. Percolation. Percolation, when we talk about percolation, it is a vertical movement of the water through the soil formation and which is joining your groundwater table. And there is a term known as permeability, which is an expression, is also a movement of the water, but it is in any direction. So you have got a permeability in the X direction, Y direction, Z direction. So that is the permeability. Specific yield means basically a ratio of volume of the water which after saturation drained by gravity. That means you take up a volume of the formation, saturated formation. The amount of water which is drained by the gravity is the specific yield. That means you take a sponge filled with water, hold it, the water which is drained out is the specific yield of that formation, that sponge. So that is basically specific. And the specific storage is the volume of the water that is either stored or takes into account or release, depending upon the total surface area of the aquifer with a unit draw. That means once you decrease the head, what is the amount of the water which it takes into account or releases is the storage coefficient or storativity what we talk about. Next one. There is a term as hydraulic conductivity, which is a constant, serves as a permeability, that is the flow of the water in the porous media and the AD direction. You have got the hydraulic conductivity in the X direction, Y direction, Z direction. There's a similar term known as transmissivity, that is the rate of water which the water which can flow through a unit width of the aquifer system. So it terms as a T. Transmissivity is the hydraulic conductivity, into B is the aquifer thickness. That means if you want to calculate the K, that means through pumping test, what we do, we calculate the transmissivity, and if we divide it by the aquifer thickness, the saturated one, then we get the hydraulic conductivity or the any aquifer system. Next one. Aquifers. What are the type of aquifers in a groundwater basin or wherever we get? Basically, three types of there: confined, unconfined, and leaky aquifer. Next one. We see unconfined aquifer. It is not overlain by any confined aquifer layer. So the bottom may be a confining layer, may be there, but overlain by the it is in the free to the atmosphere. The upper water table is direct contact with the atmosphere. Here we get basically a phreatic water level known as the water table or phreatic aquifer in the unconfined aquifer. Next one. Water, if you drill a well, then water table will be the under the atmospheric pressure, where the water pressure and the atmospheric pressure neutralizes. That will be the water table in that area. So in the unconfined aquifer, depending upon the pumping and all that thing or recharge, it is free to rise and fall according to the system. So when you recharge, the water table will rise. When you pump, the water table will fall in that area. Rise and fall is basically volume of the storage within the aquifer, depending upon how much storage is there. And the movement of the groundwater is direct response to the gravity in this particular unconfined aquifer. Next one. Confined aquifer is bounded above and below by a aquiclude, that is a clay or a confining layer. Impermeable formation, that means it does not transmit any water in that area, and it is sandwiched between the two layers. And basically here, it is the rise or the changes in the water level is basically depending upon the pressure of the water pressure in the confined aquifer. It will rise to a level where the atmospheric pressure and the water table neutralizes. And generally in the confined aquifer, the water table will rise above the base of the confined aquifer system. So water table is generally a bit higher. Next one. If the elevation is greater than the land surface, then we call it as a free flowing or the artesian wells. And where it basically the water table rises in the well, penetrate, that is known as the potentiometric surface, where the atmospheric pressure and the water pressure neutralizes, and we get a potentiometric surface or the piezometric surface. So it coincides with the hydrostatic pressure of the level of the water in that particular aquifer system. Next one. So the confined aquifer, the rises in the water table is primarily changes in the water pressure, not like in the gravity system or the storage or the recharge or something. So it is the pressure difference which gives you the rise and the fall of the water table. So in the confined aquifer, there is a small change of the storage. And it mainly serves as a conduit for conveying the water from the recharge to the discharge area. So confined aquifer does that. Next one. There are countries leaky or semi-confined one, where the upper and the boundaries are bounded by aquifer. Upper and lower are aquitars. That means they are like silt or silty clay, that's or sandy clay formation. That means they transfer some water into that particular aquifer system. They are semi-permeable and slowly transmit appreciable quantity to the adjacent aquifer system. The confined aquifer that lose or gain water from the surrounding formation are called leaky. That means if it gets water from the surrounding formation as a upper or the bottom, as a a semi-permeable formation, then it is called as a semi-confined or a leaky aquifer. Next one. Perched water table, that is a special type of unconfined aquifer. If there is a impermeable bed to a lateral extent of the limited lateral extent, a clay formation is there, but the aquifer system is unconfined, and the water stored over there, it will be the in the vado zone or the zone of adhesion. Then it is known as a perched aquifer system, a isolated one. And the impermeable barrier basically restrict the groundwater flow, and then you get a small pocket or lens of the water available in the aquifer system. Next one. This is basically zone of saturation is limited to aerial extent. Small water bearing zone exists between the main water table and groundwater surface. The zone is perched aquifer system and called as a perched aquifer, and the upper surface of the groundwater is known as the perched water table in that area. The perched aquifer has a limited thickness and the limited aerial extent. Next one. Here you get an idea about a perched water table. In the center, if you see, you have got a clay formation and above which some water is stored, and where if you drill a well in that cane, then you get the perched water table. Otherwise, you find the water table is there. You have got a confined aquifer, you have got a unconfined aquifer in the system water table, and if you drill a well and the pressure is very high, you get the flowing artesian well also, and it can be above the ground and it can be below the ground also. Next one. Now, with the basic information of that thing, you people are basically specialized in the EIA report and all that thing, where there is a small component of the hydrogeological part or the water sector, which you have to address in that thing. So you must be preparing all the reports and all that thing. So what are the essential things which are required to put in that hydrogeological report in the EIA, whatever, we'll just talk in that thing. And you people are well versed with this thing. I will just tell you the crux of the things which are to be important to be indicated in that particular report. Next one. You have an idea about the administrative map if you are preparing in that thing. Next one. Then you go for the study area, you demarcate depending upon the core area, buffer area. So a study area may be a 5 kilometer radius. Accordingly, you try to work out what is your study area map. Next one. Then you place a satellite imagery and try to describe what is the particular your study area, and basically you get this information from the Google Earth. Next one. Then you define the land use area for all the EIA purpose also in the part of the hydrogeology. So you try to tell about what is the land use and land pattern in that area, and you give the description of that. Next one. Then it's very important to have a digital elevation model. This basically talks about what will be the movement of the water in that area, the surface area, what is the drainage system and all that thing. So how the water is going to, which are the hilly areas, which are the plain, what is the general slope, which direction it is flowing. So that will give you an idea. And the subsurface also flow will be a subdued replica of the surface topography. So next one. Geomorphology, you have to give an idea about what are basically the land formations which are there. Basically, you get this information from the GSI Bhukosh that is available. So you talk about that area which is with the dissected hills, which you have got a valley portion, which are the peneplain or peneplain complex landscape of that area. You describe that. Next one. Then it's very important to talk about the drainage in that particular area, from where the river streams are flowing and which direction it is going, what are the things. This will be controlling the groundwater flow also. Next one. So what in the geological and hydrogeological aspect, you indicate the setup of that thing. You get the information of the geological and hydrogeological information from the GSI and the CGWA repository of the data. You have to have certain groundwater monitoring and water level with the maps in that section you have to give. Water level fluctuations, you have to indicate water table configuration, flow direction. Flow direction you calculate once you reduce level, you calculate in that area. Then groundwater quality map also you have to indicate. So these are all the information which you have to incorporate in your report when you are talking about geology and the hydrogeology of that area. Next one. So basically from the GSI, you try to get the information of the geological formation which are there, and especially in your study area, if you are going to drill a well and all that thing, which are the formation you are going to encounter. Next one. Then you give a geological map based on that GSI information, and you talk about what are the basic formations which are there in the surface in that area. Next one. Then you have to talk about the hydrogeology of that area. Brief description about the aquifer of the study area, groundwater condition, whether it is unconfined, confined, semi-confined, whatever it is, thickness of the aquifer system which is there, what is the average yield, aquifer parameters as per the CGWB data, because now CGWB has put all the NACUM report on the website, and from there you can extract the information for your study area also. Then depth to water level in the core and the buffer zone and the variation. So you will get the repository of the data from the India Varis for the water level and all that, and you will have your own monitoring also. Groundwater situation in and around the project area, including water level, quality data, maps, and quality issues. These all will form the part of that EIA report of the hydrogeology of the section. Then you have to get a map over there. So now once you have the water level data and you find the reduced level at each location, then you will get basically the reduced level of the water level in that area. Water table elevation you will get, and the water table elevation will help you to calculate which direction the flow of the water. Here if you see, it is flowing for the east to west direction or northeast to southwest direction. So this is the hydrogeological map you have to prepare and describe about the hydrogeology of that area and all the different aquifers which are existing in that area. What are the aquifer parameters, how it varies, what is the average yield, storativity, transmissivity of that area. Next one. So you can have the aquifer disposition of your study area. This you can extract from the CGWB NACUM report, and you can indicate what are the cross sections, what will be the subsurface formation if the well is drilled in that area, what are the formation you are going to get, medium sand, coarse file sand. Then in the basement you can have a nice schist or quartzite, whatever the formation. Next one. So what you have to do in the field when you go to the study, basically you have to do certain inventory and you have to monitor certain wells. You have to identify nearby wells, including active, inactive, abandoned wells. You can collect the different depth, type, casing, static water level. What is the details of the pumping system, if it is well is being pumped, what type of pumping system is there, and how much water is being discharged from that particular well. Description of any problem, whether it is a yield is low, poor, or it is okay, or there is a quality problem. These all data you collect from in your study area, and then you incorporate in your report. Next one. Then in the study area, 5 square kilometer, 10 square kilometer, whatever the score and buffer zone, you have to do certain water monitoring you have to do. It is generally as per the SOP of the CWB, we generally say that 10 to 12 observation wells within 5 square kilometer and 3 to 4 wells or 4 to 5 wells outside, so that you can have a control about the water level and water table in the entire. So these are the primary data you have to collect while defining in a study area the groundwater situation. Next one. Then you have to talk about the depth to water level, pre-monsoon, post-monsoon, and seasonal variation. These all maps you will prepare based on the primary and the secondary data available in your for that particular area, and accordingly you have to prepare the map. The primary data collected during the field, you will delineate the pre-monsoon, post-monsoon, and the year of data, which year data is there, that you have to mention. Next one. So this is basically an example that you have got the data from India Waris in your study area. So these are the sites area. You have got the lat long and the pre-monsoon, post-monsoon data is available. And what is the seasonal fluctuation? Next one. Similarly, these so many wells, 32 wells have been in nearby the study area. Next one. So based on that, you will prepare the depth to water level map based on the data of CGWB. So in general, what is the situation of the groundwater in your study area? It comes out to be. Next one. This is the pre-monsoon one. This is the post-monsoon. Next one. And then you get a seasonal fluctuation, whether there is a fall or the rise in the water table over a period of long term. What is the system in that area? So these all information is available in India Waris. Next one. Then this is the primary data which you collect during your field visit, and then accordingly you prepare the water table elevation map and you try to give the groundwater flow direction. Next one. So this is basically the depth to water level map, what you get based on the primary data you collect in that area. This you will indicate. Next one. Then it is important that you have got some observation wells of the CGWB or the State Department. Accordingly, you will try to give a long-term behavior, because in your hydrogeological chapter in that thing, you will talk about long-term behavior, whether it is a long-term trend is declining or a rising trend, whatever there. So that will give you an idea over a period of time, what will be the situation of the groundwater in that area, or the ambient groundwater situation will change in over a period of time. Next one. So you try to give a hydrograph, this sort of thing is mainly a 10-year data. You try to plot and you see that over the period area, you have got a declining groundwater level or declining groundwater trend. Next one. Then comes another aspect is the water quality. So you have got data from the water quality from India Waris. That data is there. Whenever you are visiting, you are monitoring, you are also collecting those data, and you will be preparing certain maps in that thing. So it is basically here more in groundwater, we are interested more in the EC or the TDS, whatever we call about, then the fluoride, nitrate, and electrical conductivity, chloride map. And if there is a arsenic problem, and then accordingly, or a heavy metal problem, that only you are interested. So you have got a list of parameters that you do. Samples to be collected both from core and buffer zone. It should be analyzed from the NABET lab that you do. What we suggest is that basically 12 to 13 samples to be collected from the study area, 2 to 3 samples outside the study area, demarcating in the all the directions. Next one. So you try to give a map of the electrical conductivity. What is that? They basically talks about what is the salinity in the groundwater system that will decide from this map. Next one. Similarly, you have made for the chloride map. Next one. Then you got for the fluoride, if there is a high fluoride in that area or not. Next one. And there's a nitrate. So these are the basic parameters which you collect and all the thing. And accordingly, you prepare this map and describe about the groundwater quality, ambient groundwater quality in that area. That will talk about the overall situation of the groundwater in that area. So this way you can complete the hydrogeological report of that area also. So while preparing the EIA report, you have to have some surface water quality also. So next slide, please. So somewhere you try to go for the nearby water bodies or the streams, you try to collect some samples, and then you present and discuss about what is the quality of the surface water. Next one. So these are the basically, we are more interested in the basic quality, and you will, if there is a highly polluted one, then you talk about the what are the E. coli or coliform, total coliform and other things, or bacteria and all that, BOD, COD level over there. Next one. Now, based on that background, we just touch the outline of a groundwater modeling one. What is basically the essence? It is nothing but the study area we try to demarcate, and then we work about that if you initiate any activity system or pumping and all that thing, where you are suggested preparing the report, what is going to affect in 2 years, 5 years, 10 years, what is the situation is going to. So what we do is that you try to define the model area is a 5 kilometer. So what we have done, the grid size, you prepare 40 columns and 40 rows having 250 meters. That means I have discretized the entire my study area in 250 meter by 250 meter cells, and accordingly I have made 40 columns and 40 rows. So I put the elevation data from SRTM, all the, see, you have to, in the center of the notes, you have to put all the data that you put, and the layer 1, the water level observation data for the top of the unconfined aquifer that we do. And for the layer 2, what we give is that we give a gap of a meter or so, and then the piezometric surface we indicate. So layer 1, I have got 90 meters with core and medium sand unconfined aquifer. Then I have got a 60 meter of weathered and fractured quartzite at semi-confined. So that we go, and we try to give the flux boundary. Flux boundary basically is that you try to give which area where there will be lateral inflow, and that is the flux in, where there will be the lateral outflow, that will be the flux out, and from which year that you are going to start the model. Next one. So you define, I have got a 2-layer model, layer 1, layer 2, I have got top one is sand, and the second one is weathered or fractured quartzite, that is 90 meters, 60. That means my total model domain thickness is basically 150 meters where we do. So what you do is that you run the pest in that, and then you try to give a seed value. Seed value, it comes from the pest, and then it talks about, say, kx is 15, ky is 15, and kz is 1.5. And you run the model, and try to adjust your k according to the, it has to be near to the your whatever the pumping test data, the T and S you have calculated, it will be close to that. Accordingly, you have to run the model. So I have find that thing, and then I optimized, instead of 15, in my model I have taken 10. So that is the way you try to work out all the, what you require is the hydraulic conductivity, the specific yield, and the specific storage that you layer wise you indicate. Next one. So this is the grid domain area, the study area. You will see within the circle, there are some green squares, small. These are the model, these are the small grids which are. What is that? These are the inactive cells, because this area is the hills. So that is why I am not going to model this part. My modeling study will not include these green spots, squares. So these are the cells which I have made inactive. The rest of the entire circle area, we have active cells. Next one. So you get a 3D view. Conceptually, you can see now that those green spots are the hill one. So hills, I have got a inactive one, and rest I have going to model. Next one. So accordingly, for every layer, you will give the property of the hydraulic conductivity and the specific and storage. Next one. This for the layer 1. You will get for the layer 2. Next one. There's a hydraulic conductivity for the layer 2, which you are getting. Next one. This is the storage for specific yield and storage coefficient for the layer 1. Next one. This is the storage. So I have defined all the properties in this thing. That will help me to run the model. Next one. Now, if you see on your eastern flank, I have got a flux in. That means from this area, by water will enter into the system. There will be a lateral inflow. And my red part on the western part, I have indicated, and the southwestern, that is the flux out from where the water will really laterally flow out in the groundwater flow direction. Next one. So I define what are my flux conditions and all that thing with the model domain area. So I give the entire parameters for the both for the monsoon in and out. Next. Then what I do is that in my we have got a report from the groundwater resource estimation, which is published each year by the CGWB and state government combined together. Those data are available in the public domain. Based on that, what we do is that we try to get the block-wise resource. That means GEC, Groundwater Estimation Committee report, and we try to take the recharge. What is the recharge in that area? So recharge, we get the block wise. From the block, you apportionate to your particular study area. Say block maybe have 10,000 or 1,000 square meter, square kilometer. So, but your study area is 5 square meter or square kilometer or 10 square kilometer. So you apportionate that thing and accordingly you put in the model. So each of the cell you have to put the recharge data. So that you do. Next one. So this is you, if you see, so I am running a model for the 10 years. So this is the 0, 245, 365. That way I have put the from day November to I go for slowly the year 1, 2, 3, 4, 5, 10. So I take the entire recharge data and I put the data on my system or on the model system to run. Next one. Similarly, I do water. From that resource, I get the water draft. What is the draft of that? The draft data is also there available in that. What is the groundwater extraction? That also I apportionate and I put in my model system. Next one. So this is my draft. This is the draft which I have put in. In addition, I have also put the additional draft in my project area. Some for which project I am studying, there is a industry which is drawing this much. So those draft by PP, the project proponent, that also I add into the model system, and then I will, because my area will run about the recharge, the draft, and the additional draft by the project proponent for which I am doing the EIA study or the hydrogeological study. Next one. Now, based on that thing, now I fix in that what will be my initial piezometric head. So this is my water. So this should match with your hydrogeological map also. So if there is some changes, then you have to accordingly, you have to work out that my initial piezometric head should match with my hydrogeology. Then only you will have a sort of a logical conclusion about running a model in that area. Next one. So then what I do is that I try to compute the head after 1 year. What will this say? My initial head is of blue one, and the IPZ of blue one, and the red one is coming. Then I have to see a match of the initial head with the computed heads, whether they are matching on. Once I match, that means my model is going to run in a proper way. Next one. So similarly, I do it for layer 1, layer 2. Layer 1 is sand, layer 2 is your fractured quartzites and weathered quartzite. Next one. Now I do it. What is the now I once I matched it, now I will compute that if that quantum of pumping is going to take place in that area, what is going to be the situation of layer 1 into year 2, year 5, year 10. All the scenarios I will try to come out with the model output will give me all the scenario. Next one. This for layer 2, what is going to happen? Next one. And then in layer 5, the year 5, what is going to my computed head? If that quantum of pumping is going on, then what is going to be the change in the head in that area? Next one. So in the 5 years for the second layer, what is going to happen? Next one. This for 10 years. Next one. For layer 2, 10 years. So this type of output you'll get. Now what is there? Next one. What we get is that basically once we do it, I try to calculate the root mean square error. It should be less than 5. Once it comes, that means your model is incorrect. And the NRMS error, net normalized root mean square error, should be less than 10%, and which is coming. So you will calculate and you will get these data. So that will give you an idea. Yes, what is my standard error, what is my root mean square error, what is my normalized root mean square. The output will come from your model output. Once it is within the limit, that means your model is in the right direction. Otherwise, you have to recalibrate and rerun. Now, I am interested in what? In that case, modeling is basically, if that sort of pumping is done by that industry, what is going to be the drawdown in that area in year 1, year 2, year 5, year 10? That is my more important. So that thing I will come out with once I run the model, I will get an idea that after 2 years, my area will have a drawdown of 1.65 meters and my radius of influence will be 15. That means 1500 meter will be my radius of influence. Next one. Similarly, for the layer 2, my drawdown will be 1.4 meter and radius of influence will be 13. So accordingly, I will try to work out the year-wise what is going to happen. That will give you an idea whether the industry is pumping the water in the quantum is going to be a heavy decline in groundwater or not. And if it is, there is going to be a substantial decline, what are the remedial measures to be taken so that the groundwater sustainability remains and the long-term remedial measures can be addressed to that thing. Next one. Similarly, for the after 5 years, what is the situation? Layer 1, what is going to be 2.7 meters and 2 kilometer will be the radius of influence. Next one. Then this is for the layer 1, layer 2. Next one. For the 10 years now you get. So 10 years, if you see, you can see in the southern part, there is an orange color. That means that area slowly groundwater is going to drying. So that area, because you are going to pump the water. So there will be a heavy fall in that area. Next one. So this you calculate the respective drawdown and radius of influence over a period of time. That will give you an idea what is going to be the situation and what are the measures to be taken by the particular industry or by the particular project so that the sustainability of the groundwater remains in that area. Next one. So you have to come up with a mass balance, the ultimate once you do it. So if you see, it is the area is an overexploited area. That means your well, the red one, that especially this one, this particular bar, red bar on the third from the left is higher than the recharge one, which is a small bar, because the draft is higher than the recharge. That is why the area is overexploited. So once you get this sort of picture, that means your model has run in a right direction. So in the right picture of the groundwater situation. Next one. This is the output of that thing. Next one. Similarly, for the 10 years, what is the mass balance you get? So ultimately, so the mass balance will talk about what is the out from the system and what is the into the system and how it compensates. Next one. Next one. Now, this is basically a scenario where you can run the model that once you stop, suppose in 2028, I stop pumping from that industry, how the groundwater will recover. That means the resilience scenario, how the drawdown will slowly make up. So that is the situation you can come and you can indicate that if this pumping is stopped, especially by that particular industry, what is going to be the change in the situation of the groundwater. Next one. So this is going to be the layer 1, layer 2. This much will be the drawdown. Next one. So after 10 years, this will be the situation. So slowly the recovery will be there. Next one. Layer 2. So this type of resilience. So you give an idea about comparison of that thing, a resilience scenario. Next one. This gives an idea that this is the pumping business as usual will give you. This is the situation. And aquifer resilience will be the change will be the thing where this much will be the changes. That means that much will be the rise in the water table that will happen. So overall modeling will tell you an idea that what is going to be the drawdown over a period of time and how it will be compensated, what are the remedial measures to be taken. This all can be addressed once you have an output of this type of model. So briefly, I've given an idea. So basically what you do is that for the groundwater, basically you run the visual ModFlow. The version 4.3, version 10 are there, which are the latest software which works, but you have to have good amount of data. So that will help you. So that is the crux of the entire presentation. If you people have got any question, I'll be there to reply. Thank you very much.
Thank you so much, Durjoy sir, for taking time for us and sharing such an insightful and informative session. So everyone who is, sir is open for question and answer. So anyone who have questions and queries, please feel free to ask.
Skip. No.
You can raise your hand, those who are online, and one by one, you can, of course, ask your queries.
Just
शेयरिंग अपन नहीं करेगी ना?
Anybody has got anything to ask on the presentation or anything on the groundwater as such, or any problem you have faced in your study or in EIA study on the groundwater? You can ask and you can discuss. We can interact on that thing.
Hello, sir.
Yes. Please be comfortable. Sit down.
So in case of thermal power plant projects, जो रिवर्स होती है वो बहुत क्लोज प्रॉक्सिमिटी के अंदर होती है, तो उस कंडीशंस के अंदर अपन एज ए जियोलॉजिस्ट, हाइड्रोजियोलॉजिस्ट अपने को क्या मिटिगेशन मेजर्स लेने चाहिए उनको?
Okay. See, question is that the thermal power plant, there will be a reverse system which will be in the close vicinity to that plant, and close vicinity में होगा, and there is a possibility of the contamination of the surface water because of the especially from the fly ash and other things. So उसका possibility रहता है. So they should have a system of fugitive methods. उसको dust suppressions का एक proper create करना पड़ेगा. They have to take necessary precaution that the local streams और जो river system है वो ज़्यादा pollute ना हो. Also, दो इनका जो particularly जो tailings should be in such an area where that should not contaminate the river system or also the groundwater system. So tailings should be in an area, in such area जो इनका, or the ash dike का location ऐसा होना चाहिए, it should be away from the river system, so that anyway the river system is not polluted. So basically in a thermal power plant, basically it is the problem of the ash dike which is basically a major threat to the surface water body or the streams, also to the groundwater system. So ash dike is a very, very important factor in the thermal power plant. Anybody else?
हाँ नमस्ते भैया.
Sure.
बस ठीक है.
Anyone else?
Hello, sir.
Yes.
I have one question. Suppose in modeling we have more inactive area, so how we will select that area?
More inactive area?
Yes, sir. Then any criteria is there for that?
No. The criteria, see how you select it. Basically, initially you consider the entire thing as a active cells.
Yes.
So once you get a highly hill are there. So what will happen? There will be a sharp gradient between the hill area and the plain area. So that will not, you will not able to match the model properly. So that is the way you will slowly delineate those high elevated area, because that will give you a head difference, where there will be a high head difference of the water table elevation. So that is the way you will try to select the inactive area. So those inactive area will be the high gradient, high elevated area will be the inactive cells, so that will not give you a proper indication of the entire groundwater flow dynamics. So that is the way. In my presentation, I have shown you there are some isolated hillocks, small hillocks. Yes, so those I have made it inactive, because if I make them inactive, my head difference will be so high, my model will not run, and the output will be not in a correct fashion. So that is the important thing. Next one.
Thank you, sir.
हेलो सर, प्रदीप दिस साइड। सर, एक जनरल कंडीशन होती है जो थर्मल पावर प्लांट की ईसीज है, उसमें वो बोलते हैं कि वाटरशेड डेवलपमेंट प्लान डेवलप करना है। सर वो क्या होता है, वाटरशेड डेवलपमेंट प्लान कैसे करेंगे सर?
अच्छा, इसका मतलब क्या है? सी व्हाट दे वांट बेसिकली, कि जो पर्टिकुलर एरिया में जहां जिस वाटरशेड का अंदर वो प्लांट चल रहा है, so it is affecting the it is taking the water from particular river system or that. So wahan pe there is an imbalance which has been created by the thermal power plant, by the intake of that much quantum of surface water which has been taken from the river system. So what you have to do in order to facilitate the usko compensate करने के लिए आप जो कोई भी डाउनस्ट्रीम साइड में और द अपस्ट्रीम साइड में कोई भी एक वाटरशेड को डिलिनेट करेंगे, where you can do some activities which can enhance your additional flow into the river system. So आपको वो करना पड़ेगा कि ऐसे activities किया जाए, you delineate those watershed in such a fashion, which watershed में, so that some activity will create the e-flow into the river more. So that the justification for the withdrawal of the water by the particular thermal power plant does not have a negative impact on the entire ecosystem of that particular broader basin में ecosystem में नहीं हो. Otherwise the villagers will say that because of this thermal power plant there's so much water has been polluted or something. So once they take up some watershed measurements, basically to augment the e-flow into the river system, the downstream में फिर villages को पानी मिलेगा, they will not have a negative impact उनका create नहीं करेंगे industry के through.
Okay, so sir, what are those activities?
Activities may be basically activities will be some first order, second order streams में कुछ intervention करना, कुछ check dams बनाना, ठीक है, थोड़े से वहां पे वाटर बॉडीज अगर हैं उसमें उसको थोड़ा सा क्लीन करना, उसमें अगर पोल्यूशन है that they try to put some CSR funds in cleaning of those ponds. Then river system में जो है वहां पे कहीं पे e flow कम है, how to augment the e flow, those activities they will do which will add additional water during the rainy season which can flow into the entire watershed system.
Okay, sir.
सर अभी आपने मॉडलिंग के लिए 2 लेयर्स की बात की है, फर्स्ट सैंड है, सेकंड क्वार्टजाइट है,
ठीक है सर।
तो अगर मान लो 3 लेयर और 4 लेयर हो तो 4 लेयर के लिए जैसे क्या है कि अपर सरफेस सैंड आ गया, बालू रेत है, फिर नीचे क्ले आ गया, फिर क्ले के नीचे कुछ ऐसा होता है कि एक परत आती है जिसमें से क्ले, कंकर, एक्यूक्लूड जिसको कहेंगे अपन, इसके बाद में फिर क्या होता है एक शैल आएगा, फिर शैल में भी पानी मिल जाता है, जैसे धौलपुर वाला जो चंबल वाला जो क्षेत्र है ना उसमें वो मिल जाता है, लेकिन फिर नीचे एक ऐसा एक स्टेट आता है जिसको कि अपन लाइमस्टोन कहेंगे। तो उस लाइमस्टोन में भी 2-3 क्वालिटी है, कैवर्नियस लाइमस्टोन है, एक कॉम्पैक्ट लाइमस्टोन है। तो कॉम्पैक्ट में तो पानी नहीं मिलेगा बिल्कुल भी, लेकिन जो कैवर्नियस लाइमस्टोन है वो चंबल से आके पानी उस एक वेल बन जाएगा, उसमें एक जगह 2 किसान पास पास में ही दोनों बोर किया, एक 10 मीटर पे एक 50 मीटर पे, दोनों का डिस्चार्ज एक में आ रहा है 10,000 लीटर, एक में आ रहा है 1 लाख लीटर पर आवर के हिसाब से। तो उस पोजीशन में अगर अपन मॉडलिंग करें, क्योंकि कुछ वहां पे भी इंडस्ट्री है, हो सकता है हमारे पास एप्लीकेशन भी आए उस एरिया की, तो उसमें क्या फिर वो 4 लेयर लेने पड़ेंगे अपने को या 3 लेयर, जैसा है वैसे ही मोल्डिंग करना पड़ेगा उसका?
नहीं सर, जितने लेयर होंगे उतने लेयर आपको लेने पड़ेंगे। सो आपने टॉप दिया, सैंड हो गया लेयर 1, उसके बाद क्ले आ गया लेयर 2, उसको हम एक्लूक्यूट करके लेयर 2 को करेंगे, तो बेसिकली उसको वो सिमुलेट नहीं होगा, ठीक है, बट उसको लेयर 2 रहेगा। फिर लेयर 3 में आ गया आपका कंकर विथ सैंड एंड अदर थिंग्स, दैट विल बी लेयर 3, उसमें भी पानी रहता है, वो रहेगा। फिर एक क्ले आ गया लेयर 4 या कुछ अदर शेल का आ गया या सैंडस्टोन टाइप का आ गया, वो लेयर 4 हम लेंगे, वो भी हम करीब एक्विटार्ड या एक्विटार्ड लेके चलेंगे। उसके नीचे हमारा कैवर्नस आ गया है, वो हो गया लेयर 5, तो लेयर 5 वो लेंगे, एंड द लेयर 6 विल बी द कॉम्पैक्ट लाइमस्टोन। तो 5 लेयर 6 लेयर जितने लेयर आएंगे उतने लेयर का मॉडलिंग करेंगे, और उसके हिसाब से हम तो उस हर एक लेयर का हम हाइड्रोलिक कंडक्टिविटी और स्टोरेटिविटी और स्पेसिफिक यील्ड को डिफाइन करते जाएंगे उस एरिया में, तो तब हमारा प्रॉपर मॉडलिंग हो पाएगा। तो जितने लेयर होंगे उतने लेयर को लेने पड़ेंगे, ऐसा नहीं कि हमें सिर्फ 1 लेयर और 2 लेयर करना है। जितने लेयर वहां पे है उतने लेयर का मॉडलिंग रन करना पड़ेगा सर।
ठीक है सर। अच्छा, उसमें क्या है, ड्रा डाउन भी चेंज हो जाएगा? अगर मान लो अपर सरफेस का ड्रा डाउन अलग है, नीचे उसमें अगर लाइमस्टोन में चले गए तो बहुत ज्यादा कम ड्रा डाउन आएगा, 1 मीटर या आधा मीटर ही आ जाएगा उसका।
बिल्कुल सर, बिल्कुल आएगा, बिल्कुल आएगा।
ठीक है साहब, थैंक यू।
Okay, then it's everything is okay. Then thank you very much for a patient hearing.
Thank you, sir.
Thank you, sir. Sir, I would request everyone to please turn on their camera so we can take a picture. If you can also, sir, if it's possible.
Okay.
Sure. Pooja Bunkar ma'am, if you can turn on your camera. Pooja ma'am, are you there? No worries. So let's take a picture. Please, how was the session?
Nice.
Good.
Let me take one more. All right, one more. Great. Thank you so much. Thank you so much, sir. It was really informative and insightful session. Thank you for taking time for us. Thank you so much, sir.
Thank you,
sir. Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
I've shared a form in the group, so please fill that form first before leaving the meeting. Thank you.
Okay.